sorry, hold on. Almost tried to move the meeting. Trying to minimize this. Or move it. There we go. It's a branch of mathematics that focuses on the organization, analysis, and interpretation of a group of numbers. Okay? That's statistics. There's two branches, descriptive and inferential. Descriptive used to summarize a group of numbers from a research study, or inferential procedures and drawing conclusions based on scores collected in a research study and going beyond it. Bottom line is descriptive, really in our case, is totally about the makeup of the person, and that's what we're going to talk about tonight, so I don't get too much into it. Okay? Inferential are actually those certain numbers that are in something where you're going to run a specific test. So today we're doing descriptive. The rest of the time we're doing inferential. Okay? And hopefully you'll be able to see the difference as we go along. It's a test. The first one is informational. The second one is a statistical test to get you to be able to analyze. You can analyze them both, but you analyze them completely differently. And hopefully that'll make sense as we go along here. Okay? Why is that not showing up on the screen though? Oh, a variable is a single aspect or characteristic associated. Is there more? With a large group of individuals under consideration. Okay, so a variable could be as simple as burnout of high school volleyball players. Okay, the burnout is a variable. The high school volleyball players is a variable. Okay, another thing would be depersonalization would be a variable. So when you break it down into different research questions, which, okay, if you're doing a research question on that, so you would say, what are the characteristics of burnout as it relates to depersonalization of high school volleyball players? Well, burnout and depersonalization are your variables, okay? It's a single aspect or characteristic associated with a large group of individuals under consideration, okay? A parameter. Sorry, I don't know why this is doing this. Here we go. There we go. A single number summarizing in some way the values of a variable interest to population. A parameter is basically one single number. So when we do the mean, or we do the standard deviation later on, that is a parameter. A statistic is a single number summarizing in some way the values of the variable of interest. So the statistic would be something like the p-value. It would be something like almost anything really, that it's any single number. So it could be, again, the mean based on what it is. It could be a parameter, and it can also be a statistic. This one I'm going to go through real quick. This decision tree that you're seeing right now, okay, tells you what kind of test. So in this case, if you look at this, we are going to be comparing means, and we're going to be looking at the basic relationship between variables in this class. The comparing means, if you go to the bottom, we will be doing the t-test, one sample t-test. We'll be doing the independent sample t-test. We'll be doing correlation, okay? We'll also, those are the real tests that we're really going to get into, because those are the ones that are really going to be used in your capstone, along with the descriptives and frequencies on the descriptive side. Levels of measurement, okay? Binary, binary is basically two categories. Giving you an example, dead or alive, happy, sad, that type of thing. Nominal variable. There are more than two categories. It's basically a word, okay? So like a name would be a nominal variable. Omnivore, vegetarian, as you can see the example here, they are come from different categories. They won't be the same, okay? Ordinal variable. Okay, the same as a nominal variable carries the same logical order. Pass or fail, merit or distinction. I mean, they're separate. The ordinals, they have a logical order. So you're either going to pass or fail this class. It would, if we're looking at the number of people who either pass or fail my class, we would be using those as ordinal variables. Okay, the next one is continuous. Interval variable. Equal intervals on a variable represent equal distances from the properties being measured. A lot of words, okay? But think of it this way. This is a great example, okay? The difference between 6 and 8 is the same as 13 to 15. There's 2 notches between both of them. They're completely, they mean different things, but their differences between them are the same. A ratio is the same as the interval variable, but ratio scores on the scale must also make sense. So a score of 16 on an anxiety scale means the person is, in reality, twice as anxious as somebody scoring an 8. You get a 50 on the test, the other person gets 100. Okay, it would be we would look at it as a ratio. Okay, the person that got 100 was twice as good. Was he once or twice as good as the person who got 50%? Sample, population and sample. Population, everybody. Okay, so let me give you an idea. Population comes down to this. If we were going to do the census, we are going to get, as it's coming up, it's a great time to talk about this. You're doing your best to get everybody involved. Everybody. Not leaving anybody out. Okay? If I'm doing a sample, it's a selection of an individual observation. So if let me change it to Christian schools. If I want to do the population, I'm going to try and get every person that goes to a Christian college to be in my study. But that's not realistic. It really can't be done. So now we're going to a sample. A sample is a smaller size that is a representation of the total population. And here's a great, I got a couple of these. Okay. In this case, the population is here and the sample smaller. Okay. We use sampling to choose the sample. Okay. And we're going to talk about sampling a little later. And then we make an inference back to the population. So the best way I can tell you this one is, as I move on to the next slide so you can see it, okay? Understand this. When you watch TV and they say, well, whether you're a Trump supporter or not, I'm not talking about that. Trump has a approval rating. We've done a test, and the approval rating for Trump is at 34%, okay? One thing you don't know is how many people they actually called. They could have called 20 people, 30 people from the Midwest and asked this question, and they pulled out 35% of the people, of those 20 people. So you really don't know the number. When you're doing a test, you're going to tell everybody about the number, okay? You're going to let everybody know about the number. You're going to know how many participants you have. And then you're going to be able to go back and you're going to try, when you're done, you're going to be able to point it to a larger thing. So when I did my volleyball one, okay, and also my my dissertation, I could point them truly the burnout one back to the large population of all volleyball players. Couldn't quite do that for the football coaches, but there is a certain generalization that comes into it that I can really generalize it to it, but I really can't say that everybody does this. Over here on this side, I'm pointing all my data to point toward everybody being able to do it. Now we're going to get into random sampling, systematic sampling, convenience sampling, cluster sampling. There's also snowball sampling and purposeful sampling, okay? In terms of sampling, it's the process of selecting your people, period. Random, meaning I am picking people straight at random. I'm going to take, they have a random number generator. So let's say you have 1,000 people. I put my numbers into a random 1 through 1,000 in there, and it's going to tell me, it's going to pick out randomly X number of people that let's say I need 50 for the thing, and I've got 1,000. It's going to pick out different numbers and give me the 50 that I need. That means everybody had a chance, but only these people are going to get picked. Systematic sampling is easier to do than random sampling. List of elements are counted off. I can go 1, 2, 3. So I can give you an example of this. When Columbine happened, and I was working security at Wilson, and the district said, guess what? You have to do this. You have to take the wand and you have to search these people. We weren't allowed to search their bags or anything else. We had to use the wand, okay? But we had to randomly sample. We had to do a systematic sampling, and we say 1, 2, 3, 4 this time. And every 5 minutes we change the number to 5 or 3 or whatever it was. So it was very systematic in how you picked your person. 1, 2, 3, you're up. Let's check you out. Otherwise, they were going in. Made no sense. I didn't like it. Convenience sampling is very easy to do. You're just basically, if you've ever seen anybody do, I don't even know if they do it anymore. When I was young, they used to have these guys that stood in the mall, and they did the surveys in the mall. And basically, they'd walk up to you, would like to take a survey. You start to take the survey. You take it to the back room. You finish the survey. That is convenience sampling. I walk down the mall. Boom, I do this. You take the first 25 people that walk up. Boom. And then cluster sampling is dividing the population into groups, sometimes geographically, or you can put them into groups like all males and all females. All males in one group and all females in the other, okay? Purposeful sampling is more on the qualitative side. That's is where you have got to really hone down, and if you're doing qualitative, this is what you're going to do. You're going to have inclusion criteria that people were there. So in my dissertation, they had to have 5 years experience, they had to have championships, and they had to have a whole bunch of stuff before I would even talk to them. Because you want to have a very represented group in that room, because I can't have somebody with 2 years experience, never been to the playoffs, try to talk about their pregame rituals, because it wasn't going to work. I had people with 15, 20 years, and they've forgotten more of their rituals because they're so ingrained in their mind than they otherwise. And that's what we're looking for. Snowball is just like it. It's, if you think of a snowball, it just keeps gathering people. So I sit down with you, and we're going to do an interview, and I need another person, and I say, hey, got anybody that, you've heard the questions now, you got anybody you think that I could get, because I'm missing another person. I need one more person to finish this. As soon as that's done, now you've done snowball. You're asking someone else for help, okay? Variables, independent variable versus dependent variable. A dependent variable is a variable that depends on factors to be measured. These variables are expected to change as a result of the experimental manipulation of the independent variable, okay? The independent variable is stable and unaffected by other variables you're trying to measure. It refers to the condition of an experiment that is systematically manipulated by the investigator. Independent variable affects the dependent variable. Okay, for example, the amount of goal a team scores depend on the amount of games the teams get to play. So the independent variable will be the number of the games in the season, and the dependent variable is how many goals the team will score. Okay, remember now, the independent variable affects the dependent variable, okay? So the independent variable, again, would be the number of games. Sorry, okay? The dependent variable would be the number of goals. What is the effect of the different types of sport on spectators? Here, the independent variable is the different types of sports, okay? The dependent variable is the amount of spectators, because you would, the independent variable would then affect the dependent variable. I didn't know all this fancy stuff. I put all this fancy stuff in here. Here's an example. Jake averages 20 points per game he plays basketball. The independent variable here will be points per game. The dependent variable will be how many games were played.